In this video, we are going to talk about the contingency tables for finding the probabilities. Contingency tables are useful when pieces of information falls in 2 categories or more, and each category has subcategories. So let's say question 1 had 2 options, A and B, and then question 2 had 2 options, X and Y. A contingency table allows us to present the results of both the questions as well as how the 2 questions relate to each other. So for example, Miss James asked her class of 25 2 questions. Which do you prefer? Blue, red, or yellow color? And then the second question is, do you like summer or winter better? And then the results are presented in the following contingency table. So we see that the column represents the seasons for summer, for winter, and the color is the first row here. So from the table, you can answer the following question about finding the probabilities. So for example, what is the probability that the student like the blue color and also prefer the summer? So blue and summer, which is 7 out of the total of 25 students. Or you can also find the probability of the student that like the red color and the winter. So the red is right here, the winter is right here, so together there is only 1 out of 25 students. And then so on. We can find the probability of the student that prefers summer no matter what the colors that they like. So summer, we have a total of 15 of them out of 25 the total. And then the same thing for the color. If we're only looking for the yellow, then yellow we have total of 8, right, out of 25 for everything. Let's take a look at another example. A survey was taken. The subjects were sorted by income level and was either labeled as straight or not straight. So here is the result, right? So we have the income level, low, medium, high, and then straight or not straight. You see that if you have the high income and you are not straight, we have 1,899 people and so on. And then the total is just the total, the summation of the row or the column and so on. So total, we have all the subjects with a number of 6,549 people. So let's take a look at the example here. So the row totals and the column totals are the individual probabilities divided by the rand total. So in this case, for example, if you are looking for the probability of the low income, so you see that low income is the first column, and all the low income people together we have 2,480, and that is over the rand total, which is 6,549. So this is the probability of the people that have the low income in this table. The information inside the heavily bordered cells, this one, is called a joint information. So the number of the people labeled as straight, and also low income would be 526. We call it as joint information because it has both the values of low and straight. So we can also find the probability of the straight and also low income, which is 526, right? This is the joint information, and that is out of the total of all number of people, which is 6,549. And that is the probability of finding the number of the people that also have the straight and low income at the same time. Now let's take a look at more examples for this particular topic. A guidance counselor at a middle school collected the following information regarding the employment status of married couples within his school's boundary. So the results are presented in the following contingency table. We know that the first column is represent for the husband only, the wife only, or both spouses. And then for this right area, we have the number of the children under 18 years old that they have. So 0 means they don't have children, 1 or 2 or more, and then the last column or the last row, they represent the summation, the total of everything. So the first question, the first part here, what is the probability that for a married couple selected at random both spouses work? So the key point right here is both spouses work. So we know that for everything, right, for the 1,700 married couples within the school's boundary, we have 1,149 had both spouses that are working. So this is what we are looking for this particular part. And therefore, we are looking for part A, the probability that both are working. So both are working, which is this number, right? That is the total of both spouses that are working, which is 1149, and that is out of 1,700 for everything, 0.676 for everything. So that is about like 68% of all the married couples selected at random, and we have both spouses that are working. The second part, what is the probability that for a married couple selected at random, again, married couple selected at random, the couple has one child under the age of 18. So we know that again, we have a total of 1,700 married couples within the school boundaries, and only 353 of them has one child under the age of 18. Right, so only 353 of them, the total, everything here, 353 of them had one child under the age of 18. And therefore, now you are looking for what? You are looking for the probability of one child under 18 years. And we know that of course that's going to be equal to what? This much value out of everything. Everything is 1,700. And that is roughly 0.0208 or 21% or 20.8%. And then the next part, what is the probability that for married couple selected at random? So we select a random married couple from the table. The couple has 2 or more children. Okay, so 2 or more children, so it's fall into this category. 2 or more children under the age of 18, and also both spouses work. So we also include another requirement: 2 or more children under the age of 18, and also both spouses work. And that is gonna be what? This column, this row, that is 370. So we have the probability of that is gonna be equal to 370 out of the total 1,700, and that is about 37. If you simplify that into 37, 170, and that is about 0.218 or like 21.8%. The next part is what is the probability that for a married couple selected at random, the couple has no children. Okay, so has no children or only the husband work. So pay very attention to this part here. This is or. So no children, that means 0, or the only husband work, which is the husband only. So you may think that, okay, we have 0 children and husband only, then that should be this number. But that is not correct. Why? Remember, this is the OR case. The last sample, we had the AND case, so you can take the value directly from the table, from the row and the column. But for the OR case, remember, we have to use the subtraction of the common area. So go back to the case of OR. So recall that, for example, this is just the example. If I have like P of A or B, then that's going to be equal to P of A plus P of B and subtract P of A and B. So this is the rule that we saw earlier. So applying the same thing to this problem, we are looking for P of husband only, right? Or no children. So we are looking for these two specific factor. You can think of this as A, right? This is as B. So applying the rule, the same thing here, we are going to get P of husband only, and then plus P of B or P of no children. And then we're gonna subtract P of husband and children. Husband only and children. So pay attention carefully to here. Alright, so we know that the probability of the husband only. The husband only is what? The husband only, you see that the husband only is the first row, and that is 425 out of the total of 1700. Okay, and then plus P of no children. No children is the 0 column right here, and that is 788 out of 1700, everything. And then make sure you subtract the one in common, husband and children. So husband and no children, which is this one, so that is gonna be 172 out of 1700. So make sure you have to follow the OR rule in this case and get the final answer of 0.1612 or 61.2%. So that is this case is different from the last one between the OR and the AND case. Now we are doing the last part E. Let's do it here. Would it be unusual to select a married couple at random for which only the wife works? So only the wife works is this row. So of the 1,700 married couples within the school's boundary, 126 of them had only the wife working, and therefore the probability of finding the wife working only out of all of them is 126 over 1700, and that is it's gonna be like 0.074, and if you convert it back to percentage, that is like around 7.4%. And normally it would not be unusual because this value here is larger than 0.05. So normally we had a rule If anything less than 0.05 or less than 5%, then we consider that to be unusual to have. But this one is 7.4%, it's bigger than 5%, so it is not unusual because it's bigger than 0.05. So the answer here is no. It is usual or not unusual.